Okay. All right, thank you. All right, so I'm here today to talk about tetration analytics and more around data analytics. What I'm going to start off with is actually around the race. I'm going to show you some, I'm a data guy, so I'm going to show you some stuff around the actual Melbourne Cup race. And for the TV, you'll probably see, I'm going to predict some things here, and we'll see if it sort of comes out a little bit later on. So we'll have a look. So without further ado, with the Melbourne Cup, here are the stats as of yesterday. What you'll find is that mostly boys or girls, mostly boys, come in between the ages of 4, 5, and 6 years old, and that's due to being in your prime as an athlete, basically. So if you think about a 20-year-old in their prime in athletics, the same thing would happen with a horse. So if I look at this data, and I looked at this last night and basically did a normal distribution of the data, and you can see there essentially 4, 5, and 6 very much are the favorites in terms of actually the years of age in terms of coming in. So very much a normal distribution curve that you can see there. So if we just apply that to your 24 horses that are actually running today, we can easily just eliminate those things when they're on the confidence interval of that normal distribution. So what we're going to show you is basically that's your real number of horses that you should be picking today. So we've just taken 24 horses and made it down to 12. So hopefully you guys who've got your tickets today at least have picked something along in that list. And for the TV, I'm sorry you weren't here to actually to see that. So data, the point being that data really helps you make a better decision-making process. And as you can see here, we've taken very much a statistical view of how we do that. So analytics, and on to tetration. So tetration really is around that data analytics for your data center. Again, allowing you to get better decision-making capability from a data model view. What tetration does for you, it monitors and analyzes every single packet that has ever transpired in your data center, both in real time as well as historically. So we correlate every single packet, and we can go forward and back in time at any point in time within your whole data center. Where it really starts is around application insights. We see that from an application standpoint, you can map out all your applications, and we use unsupervised machine learning behind the scenes to map out your applications and really understand how your application works and its intercommunications between applications. We find that most of our customers really, or most clients, really don't understand the intricacies of their applications, so this allows you to actually do that. So from that context, as well as a visibility and forensic standpoint, from an operational context, we can go very fine-grained into finding the needle in the haystack, because we're keeping every single packet for everything that's ever happened in your data center. We can drill down to any point in time, both in real time and historically. We'll also introduce policy. I will go through a demonstration around policy controls and policy simulation. What we mean by that is actually having a distributed, consistent policy from a security standpoint across your data center, across your cloud, your hybrid cloud, whether it be on an OpenStack environment or whether it be on a public cloud environment like an Amazon or Azure or anything like that. It's really about consistent policy control across your whole environment. Continuing on the security side of things, we'll talk about policy and application segmentation, really getting to a zero trust model, so only applications talking to only what it knows about with the other applications. And from a compliance capability standpoint, governance controls around that. Again, I'll go into the demonstration. Lastly, there's some things around new additions in tetration around neighborhoods, being able to actually understand utilization of assets within your IT environments. And we go down to a process level. So every single process for your applications inside your data center, we will be looking at the hash of every process, meaning that we can actually look at that in comparisons with other applications and understand how your patching environments work, or if there's any malicious sort of behavior going on within your application itself. So again, we'll sort of demonstrate this through in a live demonstration in a minute. So I talked about the data and the data sources. So this is really where Tetration takes the data from. Cisco is very much known for the network and security side of things. Think of that, Cisco have that as a data source. So on the left-hand side, we have software. So we take, this is what we advocate very heavily, is that we want to have that rich application telemetry data from the software side of things on your endpoint or your host, whether it be a VM, whether it be a Linux or Windows server, anything along those lines, including traditional operating systems as well. Then we have on another data source, which is Cisco's own capability in the switches itself. Embedded in the switches, we have telemetry capability, so we can grab all that telemetry data from the switching environment too. And on the right-hand side over there, or on the left-hand side, should I say, you can see that third-party sources such as configuration management databases, load balancers, bring your own data really, so we can ingest anything from a data standpoint. At the end of the day, what we're looking at is a data platform using a big data engine, which is a Hadoop cluster, Apache Spark, running Druid, and having a Kafka bus at the back end. So any Kafka broker from a data streaming standpoint, we can ingest that into Tetration as well. Also new to Tetration is we look at the desktop on as well. So think about your virtual VDI environments. So we can actually look at that inside your data center. So that's pretty much the slides, and now I'm going to go straight into a live demonstration of Tetration. Okay. So I actually like to start here, which is basically a visualization aspect. So what you're seeing here is essentially your data flows in a chord diagram. So I'm looking at a very simple application. It's an open cart application. And just so you can see that properly, I'll just zoom in a little bit. So we have an open cart application using WordPress. These are flows that are happening between any of the applications itself. So these are application flows that are happening. And this is what happens after you run an application dependency run in your environment. So this comes out of the box. So once you do an application dependency run, you'll see what's actually happening in your environment from a flow perspective, how your applications are talking to each other, and this is just a visual representation of that. So if I click on that, I can see on the right-hand side, I've got specific endpoints. So I've got a couple of IP addresses there, which are essentially two servers that are being clustered. Again, this has been put in there automatically after an application dependency run. And I can see what's in the neighborhood, like proxy servers, SQL, shared services, and things along those lines, including subnets, and what ports are being consumed and what ports are being provided. But I can actually go down further than that and sort of drill down into that environment. And again, I can see all the session flows happening between those two applications. So there's my one app endpoint that I just showed you. And if I go on the right-hand side, I get more detail about what's actually behind that. So I can see that this is going through a load balancer. I can see the virtual IP address. I can see route tags. And even down to, as I was saying before, around the process level. So I can see the user and the process for every single element that you're looking at within your data center if I needed to, which is very powerful in that I can actually drill down to this level of detail at any point. Also, I can see anything around the ports being used. So if it's in black there, it's being used. If, for instance, I've got a grayed out port over there, that's actually meaning that it's not being used. So in terms of, it's actually an open port that is not in use. So from a security side of things, you might want to look at bolting that down and disabling that as an example. And this can show you this pervasively across your data center. So you want to really reduce that attack surface area from a security standpoint as an example. So again, I can see what ports are being provisioned, what ports are being consumed at any point in time. So that's one look at it. And if I actually look at it from another view, which is essentially saying the same thing, straight out of the box after an application dependency run, what will happen is it will put together these rules, like a firewall rules. So automatically I will see how my applications are talking to each other, and it will dynamically create all these communications between my endpoints. So I can actually have ACLs that are right out of the box, straight out from an unsupervised machine learning algorithm that brings this together and puts it out for you. And this is what the applications are actually saying themselves. So this gives you a rule set that you can work against. And that's what the applications are saying. And I can even put absolute policies on top of that, meaning that that's what a user might want to do in terms of actually user intervention over the top of what I'm actually seeing in my environment today. So this comes out of the box, as I said, with once you run an application dependency run, and gives you that level of capability. What also I'd like to show you is around the application view. So the same data re-represented in terms of an application view. On the right-hand side, I can see all my shared services, like things like NFS and SQL. In the middle there, I can actually show you data flows in terms of which way they're going. So I can see WordPress going through a load balancer in a directional format into OpenCard itself. And I can see the same thing happening with HA proxy. So again, it gives you that sort of level capability in terms of identifying and mapping out your applications and seeing the directional flows plus all the ports and processes and everything around that you might want to see at any point in time. So that's really from an application dependency standpoint. Then I go straight into more of an analysis view, where I can do here is I can actually monitor my traffic in real time and put those policies that I've just shown you on top of my traffic. So I can take a time range of any point in time, really. So I'll take maybe a few weeks, and you can see it's like 77 million observations that I'm looking at from my network. And I could look at anything that's going across. So I can see my permitted things from a policy standpoint, or things that are missed, dropped, or escaped. What I'm normally interested in is escaped flows, meaning that it's gone outside of my policy and I want to see what actually is happening there. So I can click on any point in time and see my escape flows. And if I go down here, essentially I can get even more detail in terms of what that actually might look like, and see what policy is picking that up. In this case, it's a denial as an example. So I can drill down into any point in time and look how my policy is being applied to that. Additionally, I can sort of run experiments. So from a simulation standpoint, or if I want to go and test policy controls with my data in the past, I can actually go and do that and put a test policy across here and go and run my data, my policy against my old data. So I can do that as well. So I'm really going very quickly here, and I'm going to run through the rest of this platform. But essentially, I want to show you some flows. This is how you'd actually look at it from a flow search standpoint, being able to go across millions of observations at any point in time and be able to identify what went wrong, when, and how. So really, again, giving you more data behind your decision-making process again. So if I just select a select few amounts of data, in fact, I'm going to change this to a different scope called a Microsoft scope. If I look at this, what I can show you, I can look at a period of time going back for a couple of weeks. And what I'm going to do is I can filter on a number of different things, whether it's host names, whether it's processes, whether it's actually countries or ports, or it really doesn't matter. So over here, I'm going to essentially look at observations, but I can change this down to something more meaningful like application latency. And when I look at that, on the right-hand side, I've got things like SQL 02 over there. I'm just going to simply add that into my filter as an example, and just filter on SQL 02 in terms of what I'm looking for from an application latency standpoint. So when that comes back, again, it will show me in this range or any time in that range. I can see metrics around application latency from a SQL Server standpoint, or anything else that you might be looking for. So I'll click down on that to get a little bit more granular. And essentially, you'll be able to see number of bytes being sent, and down to server response times, down to network latency and application latency at any point in time. So again, if you're looking for your problems within your application space, you can actually drill down to per packet anything within your data center. So giving you a very, very fine level of capability that you probably haven't had before. Thinking about like how long it would take you to resolve issues around this from a network and an application standpoint really comes into its own just along that. And similarly, if I want to look at exploring different flows, what I can do is I can look at this from a an aggregated view where I can say how many flows are happening across this SQL server as an example. And what I can see here is a lot of flows are happening, which might not make sense. So I can actually look at specific dimensions that would make sense to me. So I can clear that, and I can show you, for instance, we'll go and have a look at the host names and the ports and the protocol and maybe some application latency or something along those lines where it would sort of make sense to us. Maybe server response as well, the round trip time. And there you can see with this SQL server, I can see these thick dark lines representing a normal flow in terms of how that looks. If it's faint, it means it might be in an outlier. Like these sort of dots over here, so we can go into an outlier view where we'd actually see things that are not normal or deviant to our expected behavior. Similar to the horse races that's going to happen probably in 20 minutes, where you'll see some 8-year-old horse sort of winning the races or something like that. But I don't think that will happen. So so that's really the flow side of things. We can go into the inventory side too. So meaning that we augment configuration management databases. We keep process levels, as I've mentioned before. I'm going to just quickly do a search on that same SQL server quickly. And if I go down to this host as an example, I can go down to the endpoint. And here, as I was saying before, around the processes, because we're tracking all the processes in themselves, you can see the actual hash of that process. So in this case, there's the process identifier. You can see the user. You can see what the actual process is from a command line perspective, and that's hashed. So that can be hashed against everything that you're seeing within your environment. And again, you can look at that from a malicious standpoint from security. You can look at it from a patching systems. Think of WannaCry as an example, right? So very easy to put those things together. Additionally, what we have is around the data platform side of things, where we can see cloud migration. Now that's a new feature in here. What you'll find with a lot of cloud providers is the data costs associated with going to cloud. How much is that data cost? So because we're collecting all the information at any point in time, we can actually monetize that. We can see how much data is going to be used at any point in time, and you can put that together. And I'll just show you quickly around the neighborhood side of things. Just switch over to here quick. What we do from a neighborhood side of things is we can actually, because we have this definition of scopes, meaning that one user environment can see another user environment, and we might want to be able to see what's outside and what's inside. So you might have different scopes in terms of multi-tenancy or something along those lines. We can actually show you interesting traffic around anything along those lines too. So I'm just going to quickly show you what that might look like. Let's try that again. Oops. Whilst I just get this together. Hang on a second. I'll just do it this way. Okay, I'll just show you from this one here. So what I'm showing you here is, everything. These are all our labs within our environment, and essentially, as I said, one scope can see another scope. So, for instance, these are labs It goes through a gateway. So what is actually going through that gateway at any point in time? I can sort of click on that and see only 2 ports are open, and this amount of traffic has kind of gone through that. And I can actually go again into a more granular view and see that in an actual network context that I was showing you before from a flow search capability. So I can really take that and switch it back into a context of fine-grained controls from a network standpoint as well. Outside of that, from the data platform, what you can do is you can build your own applications on top of this in your favorite language, whether it be Python, whether it be Scala. Scala is much more of a data science sort of, or R or something like that. But yeah, your own languages that you can use to build. We give you programmatic access into all your data that's ever happened within your data center down to a process level that I've hopefully just been able to demonstrate to you in a very, very quick time. This normally takes a lot longer to demonstrate, and normally I'd take about an hour to do this, so I think I've just done it in record time and pretty much on the money. But just last slide quickly. I think I'll go back a couple, just for anyone who missed it before. Data making a better decision model. These are the actual winners of the selection of the race today. So just so that you know that, and thank you very much for your time. Okay, thank you.